today we are going to look at the vector value functions taken from FKE2 University to Principal Combination. This for definition of vector value functions. If in the 2D plane or the 3D space, a vector value function is actually R is a function of t equal to fti plus gtj. Is a vector and is not constant value, but it's a function of f and gt in the unit vector I and j directions, or another notation to represent the vector with the lesser symbol and greater symbol separate by comma. So this is a fti, this is a represent the gt, or in 3D space we have the z direction, we have the unit vector k. So in the another notation ht. This is vector value functions in plane and space. For example, if you have a ft equal to 3t squared I plus 2t cubed j plus t minus 2k phi r1, r2 and r0. Find r1, r2 and r0, just plug in r value by 1, now by 2 and by 0. So we want to find r1, plug in t by 1, square this component I plus 2, t is 1 plus 1 minus 2, 3i plus this component j, 2j, 1 minus 2 is negative 1, okay. So this is r1. Similarly, if you want r2, replace t by 2, okay. So 2 squared 4 times 3, 12i, 2 cubed and 2 to power 4, so 16j, 2 minus 2, so you have 0, this is R2. If R0, then replace t by 0, component I will have 0i, component j also 0j, so 0 minus 2 we have negative 2k, this is only negative 2k. Or you want it in this notation, or in this notation, in 0, comma, 0, comma, negative 2. So this is how we evaluate the vector value function. Later on, the domain of vector value function, the domain of Rt is a set of intersection of each component function. Example 1, we find the domain of the vector value functions Rt equal to ln t minus 1i plus exponent tj plus sec tk. So it finds a domain at each component ijk. Okay, so for component I, C. To get the domain for component I, you have a ln t minus 1. Okay. For the ln function to be defined, we have to set t minus 1 greater than 0. That's why t is greater than 1. Okay, for component j, okay, the domain t is actually can pick up from negative infinity up to positive infinity. Component k, in order the square root function to be defined, t must be greater than equal to 0. Okay, then the domain scape is actually intersection of, okay, initially from component j, the domain is actually from negative infinity to positive infinity. Okay, however, component I state that its t must be greater than 1. Okay, component k t greater than equal to 0. Okay, so the combinations should be the result is intersection of t greater than 1 and t greater than 0. Okay, so this is t. Okay, only one direction. Okay, one said t. Let's say this is 1, this is 0. T greater than this is t greater than 0. Okay, this one t greater than 1. So the intersection will be here. Result, okay, the domain, okay, will be actually lastly is t greater than 1. That t is a real number. Thus, the domain for vector value function is actually the intersection scale of the intersection of each component. That's why the result is actually t greater than 1. Okay, example 2, find the domain of a vector value function. Okay, rt equal to ln ti plus square root 1 minus tj plus tk. Okay, and then from component I, okay, for ln function to be defined, t must be greater than 0. Okay, for component j, okay, for square root function to be defined, 1 minus t must be greater than equal to 0. So 1 greater than equal to t, so t less than equal to 1. Component k is actually a linear function. T is actually belong to real number, and from negative infinity up to positive infinity. Okay, so the intersection is actually we have t greater than 0, we combine intersect these two, t greater than 0 but less than 1. That's why the domain is actually greater than 0, okay, but less than or equal to 1. And the t is a member of real number. I want to put identity not equal to 0 but greater than 0 but included 1. So this is round bracket, this is square root bracket, stand for included, not included 1. Now this is a second example. So all the parametric equations in vector form. Okay, a vector value function, this is in 2D, rt equal to fti plus gtj. As a parametric equation, exactly component I, let it equal to x. So x is ft, component j, let it equal to y, and y equal to 3t. Okay, if in 3D, a vector value function rt equal to fti plus gtj plus htk, we have a parametric equations of x equal x. Component I, let it equal to x, so x equal ft, component j, let it equal to y, component k, let it equal to z. Okay, and then now we look at the graph of vector value functions. It's a parametric curve represented by the parametric equation corresponding to rt. For example, describe the graph of rt equal to 3 minus ti plus 2tj plus 4 plus 3tk. In the previous page just now, we said you let the component I equal to x. That's why you have it. So that's why it's actually in this part. We have actually x equal to, we have x equal to 3 minus t, component j, let it equal to y, so y equal to 2t, z equal to 4 plus 3t. Okay, this is actually the okay, parametric equation of the linear equations in 3D space. Okay, where okay, exactly is a line, it goes to a point. Okay, this 3D space will go to a point, okay, where you let, okay, actually when here 3 minus t, so you're going to the point 3, and then 2t is actually you have 0 plus 2t j. So passing through the point 3, 0, 4, and parallel with a vector. The vector, you take the coefficient of the t here, which is negative 1, 2, and 3k. When you look at the parametric equation like this is actually, okay, this parametric equation we're passing through, this is 0 plus t, 3, 0, 4. Coefficient k for the t is actually a vector which is parallel with this parametric equation, which is negative 1, 2, 3. Because okay, we call back, we have a parametric equation for a line in space as x equal to x naught plus at, y equal to y naught plus bt, and z equal to z naught plus ct. It's actually going through the point. Okay, we'll go through the point here, x naught, y naught, z naught, and parallel with a vector which is okay at the ai plus bj plus c. Okay, that's why okay, this vector value function going through, okay, or passing through the point 3, 0, 4, and parallel with a vector negative 1, 2, negative 1i plus 2j plus 3k. Example, okay, sketch the graph of rt a rt equal to cos ti plus sin tj for t from 0 to 5. Equation B is rt equal to 2 cos ti minus negative 3 sin tj, where the t from 0 to 5. We have component I, let it equal to x, component j, let it equal to y. Okay, and we make square root, okay, both parametric equations. So you take away the square root we have here. This one, when you square it, you have x squared equal to cos squared t, y squared equal to sin squared t. So you add up cos squared t plus sin squared t equal to 1. Okay, which is, and cos squared t plus sin squared t equal to 1. So this is actually represent, we have a circle with radius k1 constant. And for the polar coordinate, cos squared t plus sin squared t is what? Is your x squared plus y squared equal to 1. Okay, therefore r squared equal to 1, r equal to 1. So it tell you this is a circle x squared plus y squared. Cos squared is actually x squared. Sin squared t is actually y squared. So you get x squared plus y squared equal to 1. Or this is a circle equation which is centered at origin with radius 1 units. So that is a equation A. Okay, and vector value function. Vector, we have the magnitude and direction. To determine the direction, we just substitute the starting point when r equal to 0. Okay, so when r equal to 0, when r equal to 0, so you have of here when r equal to 0, cos 0 is 1, sin 0 is 0, so means starting point is x is 1, y is 0, starting point here. Okay. And then if I put 2 pi, later on you'll get at the same point. So I don't know where is the starting point, where is the ending point. So let's say I put r equal to pi over 2. Okay, cos pi over 2 you have 0, sin pi over 2 is 1. We move to the point x is 0, y is 1 here. So the direction for this vector value function is anti-clockwise. Yeah, I don't put the 2 pi because when you put r 2 pi, cos 2 pi 1, sin 2 pi 0. So you don't know because the same point. That's why I put r equal to pi over 2. And you can know the direction is actually anti-clockwise. For question B, x equal to 2 cos t, y equal to negative 3 sin t squared left hand side. Okay, we have x squared equal to 4. Okay, 4 cos squared t. Or x squared over 4 equal to cos squared t. Okay, you squared this one. Y squared equal to 9 sin t, or y squared over 9 equal to sin t. Okay, add up cos squared t plus sin squared t. Cos squared t plus sin squared t, you know this one. Cos squared t is x squared over 4. Y squared t, sin squared t is y squared over 9, so equal to 1. So this is an ellipse equation where the ellipse is centered at origin, x equal to 0, y equal to 0. The intersection of the ellipse will be from negative 2 to positive 2 at the x-axis. On the y-axis here, it will be from negative 3 to positive 3. It's given x squared over 4. When you let y 0, x squared equal 4, so x will be positive negative 2. Okay, to find y-intercept, you let so x 0, y squared equal 9, so y will be from negative 3 up to positive 3. So the second vector value function r equal 2 cos t, okay, negative 3 sin t, exactly an ellipse. Okay, and the directions because from you want to know a direction whether anti-clockwise or clockwise, then plug in with r 0. Cos 0 is 1, so 2. Sin 0 is 0, so it's from the point here to this point. So put r equal to pi over 2. Cos pi over 2 is 0. Sin pi over 2 is 1, so 0 to negative 3. 2, 0, starting from 2, 0 to 0, negative 3. Remove the key. So this one, the direction is clockwise. So for question B, the directions of the vector value function is clockwise. Example, sketch the graph of r. Okay, this is in 3D. Rt equal to cos ti plus sin tj plus 2k. Where the t from 0 to 2 pi. Okay, rt equal to cos ti plus sin tj. Okay, however, okay, the component k is actually t2. So for question A, you know if in 2D only cos ti plus sin tj is actually a circle which is centered at origin. Okay, origin, and then the direction is anti-clockwise because from this component, this two part. This part is actually similar to I sin tj. We have a circle centered at origin with radius 1 unit and the direction is anti-clockwise. However, z is equal to 2. Without the component 2k, we have actually a circle centered at origin and then with radius 1 unit. they travel in the anti-clockwise direction, and then from component K, Z equal to 2. So means your circle is moved up to the position Z equal to 2. But from here, when you square that, cos squared t plus sin squared t equal to 1. Cos squared t is your x squared, sin squared t is a y squared, so y squared equal to 1. So component I and J tell you it is a circle centered at origin with radius 1 unit, but because it is in 3D, and here Z equal to 2, so this is that this circle is moved up to Z equal to 2K position, and this anti-clockwise because when Z then t equal to 0, 0. So component x cos 0 is 1, sin 0 is 0. So this is x, this is 1, and r pi over 2. Cos pi over 2 is 0, sin pi over 2 is 1. So x is actually x 1, 0, x 1, y 0. Move to x is 0, x and y is 1 is 0. So that's why anti-clockwise. Now we look at question B. I and J tell you is a circle, K direction, circle with radius 1 unit and it's 1. However, the component K is actually Z equal to this is we calculate the value of x, y, z at t from 0, pi over 2, 3 pi over 2 to 2 pi. And the z value is increasing, say t from 0 to pi. Actually, I think I draw up to 4 pi. This one is sketch up to 4 pi. Here your vector value function is the black color. Like some car park, it's a spiral shapes like this. This graph is called as a helix. Compared to just now, if K here is 2, you have a circle only. Circle at position Z unit. But now, if you let's start at this point. T 0. Cos 0 is 1, sin 0 is 0, Z is T, so it's 0. So we add here, starting point. X is, this is X, and this is 1. The starting point, X is 1, Y is 0, Z is 0. Later on, pi over 2. T, so you raise up. X is 0, cos pi over 2 is 0, sin pi over 2 is 1, Z is pi over 2. So we move to the point. X 0, Y 1, but Z raised up pi over 2 unit, so at here. Later on, pi. Cos pi is negative 1, sin pi is 0, Z becomes pi. Then we can put that. X negative 1 here is good. Up here, up to here. Increasing. Z now become pi. X is negative 1, Y is 0, Y 0, but Z raised up to pi. And then later on when 3 pi over 2, cos 3 pi over 2 0, sin 3 pi over 2 negative 1, Z is 3 pi over 2. 3 pi over 2 you move up to here. This one. Z 3 pi over 2. Z keep on increasing. And then when 2 pi, cos 2 pi is 1, sin 2 pi is 0, Z is 2 pi. So if only one cycle, you actually move in circular directions, but the height is increasing. In circular direction with the radius 1 unit, some sort like this is a car park with a circular, okay, bounded by circular area. We play this one unit. So the z is initially z0 up to here, z is pi over 2, move up to here, back, z already, okay, pi, this is pi. Go here, z up to this point is 3 pi over 2. Put up one side circle here. 1, 2, 3, 5 point, right? 1, 2, 3, 4, 5. Here, z already 2 pi. Okay. So this graph is called as a Herlich graph. Okay, later on, we look at the limits, derivative, and integral of vector value function. Okay, if Rt equal to Fti plus Gtj plus Htk, the limit for Rt when t approaches to A exactly is a limit of Ft when t approaches A. We find the limit of each component separately. Limit of Gt when t approaches A. Limit of Ht when t approaches A. Okay, and then to find the derivative of drdt or r prime t, you ddt each component. So this f prime t, g prime t, h prime t. To do the integration, you integrate each component. Okay, so this is the finite integral, this is the finite integral. For example, let the Rt equal to t squared I plus etj minus 2 cos pi tk. Okay, then limit of Rt. Okay, limit of Rt when t approaches 0 to the limit of t squared when t approaches 0. So plug in t equal to 0. 0 I. Plug in t equal to 0, exponent 0 is 1. So you have 1j. Plug in t 0, cos 0 is 1. So you have minus 2k. So j minus 2k. To differentiate k up to get drdt of r prime t. So in ddt t squared, we have 2ti. ddt exponent tj equal exponent tj. ddt negative 2 cos pi tk. Differentiate cos is negative. So negative positive 2 sin pi k, and then ddt pi t is have a pi. That's why the answer is 2 pi sin pi t. ddt this one positive 2 sin pi t, and then multiply by 5 at the component k. And if you want to find, evaluate the r prime t at t equal to 1, then plug in t1, you have 2, exponent 1 is t1. When t plug in by 1, sin pi is 0. That's why the answer is 2 pi plus exponent j. To evaluate the Rt from 0 to 1, we evaluate it at each component. We integrate t squared, you have t cubed over 3. Evaluate it from 0 to 1, you get 1/3 I. We integrate exponent t, you get exponent t. Evaluate it from 0 to 1, you get exponent 1 minus exponent 0. Exponent 0 which is 1. Okay. Integrate negative 2 cos pi t. We have for this one. Integrate negative 2 cos pi t at component k. Integrate cos is sin. You get negative 2 sin pi t divided by pi. Integration we divide by pi, multiplication we multiply by pi. Integrate cos negative sin, integrate differentiate cos, integrate cos positive sin, differentiate cos negative sin, and then so evaluate it from 1 to 0. Sin pi is 0, cos sin 0 is 0. That's why the answer is 1/3 I plus exponent minus 1g. The second example, integrate 2ti plus 3t squared j dt. So this is a indefinite integral. So integrate 2ti plus 3t squared j dt. So we integrate each component. Where t squared over 2 plus this is c1 component I plus integrate 3t squared at component j, you get t cubed plus c2 at component j. T squared I plus 2 cubed j. So the c is actually c1I plus c2j. The properties of derivative and integrals. Okay, let Rt, R1t, R2t be vector value function. Let R1t, R2t, R1t, R2t be vector value functions. Ft be real value function. K is a scalar and C is a fixed constant vector. Okay, and the rule of differentiation, if you ddt a constant C, the answer is 0. If you ddt k time of Rt, since the k is constant, so the k time R prime t. Okay, if you ddt R1t plus minus R2t, this is a linearity property, then we have actually R1 prime t plus minus R2 prime t. Okay, this is product rule. ddt R, okay, ft rt. Once you have a product rule, you have a, okay, your like the uv, so this is u v prime plus v u prime. This is a product rule. This is a quotient rule. ddt rt or ft. So we have v. V is a denominator. ft. V, this is a u prime. R prime t minus u v prime divided by v squared. The product rule. The product rule. So that this is u v. So v u prime minus u v prime. This is u v prime plus v u prime. Okay. This is ddt dot product, ddt cross product. It follows the product rule tools. So like R1t dot with the R2 prime t plus R1 prime t dot with R2t. For the product rule, in the cross product also satisfy the product rule here. Okay, R1t cross with R2 prime t plus R1 prime t cross with R2t. For the rules of the integration, okay, integrate k time of Rt dt. K is a constant, so you factor out the k. So integrate Rt dt. Okay, and this is linearity property. Integrate R1t plus minus R2t dt is equal to integrate R1t dt plus minus integrate R2t dt. This is a linearity property. Okay, example 1. Okay, if R1t equal to 2t, 3t squared t cubed, and Rt is 0, t power 4 pi. Okay, ddt R1 are the product of R1 and R2t. ddt the cross product, this dot product, this is cross product of R1 and R2t. Okay, the first method is actually you price a product. The first method is actually you DDT. You find the product rule first. Okay, to do the product rule, you click component I multiply I, 2t times 0, and then 3t squared times 0 is 0. Lastly is, after you have t power 7 here. Later on, you DDT t power 7, you get 7t power 6. Okay, method 2 is applies using the formula. Using this formula. Okay. R1t dot with R2 prime t. R1 prime t dot with R2 t. So for me, the method 1 is easier other than the second one. Okay, method 2 is actually we have R1 t, R2 t, and then using the formula we find R1 prime. Here. So DDT 2t you have 2, DDT 3t squared you have 6t, DDT 3t squared you got t cubed you got 3t squared. So you have R1 and then R2 prime 0, 0, 4, t, 3. So will be the using the formula in your DDT R1 dot R2 is actually equal to R1 dot with R2 prime plus R1 prime dot with R2. Okay. So this is the R1 dot with the R2 prime plus R1 prime here dot with R2. So using formula, you need to do two kind of dot product. Directly we do dot product first, then on DDT. I think this one much easier. Okay, and then doing the dot product, component I times I, j times j is 0. So you got component k, t cubed times 4t cubed, now that's 4t power 6. Okay, component ij is 0, so it's 3t squared times t 4, 3t power 6, so total is 7t power 6. So method 1 is easier. And then now DDT R1t plus R2t. Also you have two ways. It's either method 1 you do the cross product of R1 and R2t and then you differentiate it. Okay. So this is R1, this is R2. Okay, and then you do the cross product. Cross product, the result is a vector. So you got component ijk. To get component I, close component I. Then you have here 3t squared times t power 4 minus it 0 times t cubed. That's why the answer you have 3t power 6. Because here, this one minus here. This is 0. And then on the component j. Okay, component j is actually, for component j, still the same thing. We have a 2t times t power 4. But component j is negative. Huh? 2t times t power 4 is 2t power 5. Minus with product of 0, so is 0, is component j. Okay. And then component k, what's it? So this one and this one 0. Then we do the DDT this one. DDT 3t 6 minus 2t power 5 component j, so component only, That's why the result is 18t power 5 at component I minus 10t power 5 at component J. And second method, a bit troublesome because you need to do 2 times cross product. So I will prefer the first method without remember the formula. Second method, you have to do 2 times cross product, troublesome. R1t cross with R2 prime t plus R1t cross with R2 t. So this is R1, differentiate it at each component. So you have 2, 6t, 3t cubed. R2, differentiate it at each component, so 4t cubed. So first of all, find R1 cross with R2 prime. Okay, this is a result. Okay, to get the result, so I close here. So this one, 12t power 5, component I. Okay, for component J, and then okay, component J is negative. So 2 times 4 is 8. Okay, is 8t power 4. Okay, component J is negative. This one is 0. Okay, component K, close this one. Okay, the product is 0. So this is a R1 plus R2 prime. Later on, you have to find the R1 prime cross with R2. So this is R1 prime cross with the R2. The component I, 6t power 5. Component J, negative 2t power 4. Component K, 0. Later on, DDT, the cross product R1t and R2t to add up is 2. 12t power 5 add up is 6t power 5, so total is 18t power 5, component J, negative 8t power 4, add with negative 2t power 4, so total is negative 10t power 4, component K, 0. This one is the method 2 troublesome. First one, just need one product rule and then you DDT the result product rule. So same with just now the dot product. I would prefer you find the dot product first, later on you it will be much easier and faster. Okay, and then the example 2 finds the antiderivative of R prime t is equal to cos 2t minus 2 sin t. Component K is 1 over 1 plus t squared, which satisfy initial condition R0 equal to 3, negative 2, 1. We want to anti-gravity, so means we want to find RT. Once you have to integrate R prime t, we will get RT. Equal to integrate cos 2t, this at component I dt minus 2 times integrate sin t, this component j dt, plus integrate 1 over 1 plus t squared with component k dt. Okay, so integrate cos, we have positive sin 2t divided by 2. Okay, and then I will add up the c together. Okay? The c, c1, c2, c3 add up as a big C. Okay, so this is component I. Okay, and then integrate sin is a negative cos, so negative is positive 2 cos t. Integrate 1 over p1 plus t squared is actually arctan t. This is arctan t, and then for integration we plus c. C is a c1, c2, this component here, c1 from component I, c2 from component j, c3 from component k. Okay, to get the c, we will have to plug in the initial condition. So we plug in the initial condition, integrate r prime t dt, you get that rt, so r0. Substitute when t0, sin 0 is, sin 0 is 0, cos 0 is 1, okay, cos 0 is 1, and then tan 0 is, tan 0 is 0, tan 0. Tan 0 is 0. Tan 0 is 0. Okay, so plus C. And given that T0, R0 is actually, we have got 3, negative 2, 1. So equal to 0, 2, 0 plus C. So you find what is a C. C will be your 3, negative 2, 1 minus 0, 2, 0. So 3 minus 0, we have 3. Negative 2 minus 2, negative 4. 1 minus 0 is 1. So C is 3, negative 4, 1. Once again, we got RT will be, this is component I, J, K. So will be your sin 2t over 2 plus 3. Component I. Component J is 2 cos t. This component J at up, so minus 4. Component K at 10 t plus 1. This another notation to write the vector. Instead I put up this is I, J, K. So you notice K for indefinite integral to get the constant C, we must have the initial condition supplied so that we can solve for the value of constant C here. Okay, and those who are interested how to get the integral of 1 plus t squared. Squared. If we let t equal to tangent theta, t squared is tangent squared theta. Okay, so this will become 1 plus tangent squared theta. Okay, so dt differentiate tangent is secant squared theta. Dt will be secant squared theta. 1 plus tangent squared is actually secant squared theta. This time we have 1 with theta. integrate 1 respect to theta, yeah, theta. Okay. When the theta is what? Times p. Okay, that's why just now we integrate 1 plus t squared, we get the arc times 2. So just now this part. Integrate 1 over 1 plus t squared, we get arc times 2. Okay, so today we have covered actually what is a vector value functions, how to view the vector value function as a graph in the graph of vector value function, then how to find the domain, limit, how to differentiate, how to integrate a vector value function. Okay, so please thank you for your attention.